This is an effort on the CMS project and the CMS applications team. Just a quick intro so you know who CMS applications represents. We have Sabrina Delgado, Molly Brown, and Lucia Wu, which I think exited to the other room, and myself, I'm Vanessa Escobar. So the CMS effort is, well, it was started back in 2010. Congress appropriated funds for it, and it's in its fourth year of existence. Applications for CMS really is about connecting stakeholders and decision makers to the, how many? We have 35 carbon products that are being developed through the CMS effort. They all connect to ocean, land, and atmospheric carbon science. So today's speaker is going to focus on ocean acidification, and he comes to us locally from DC, from the Ocean Conservancy. So we have Jeff Waters and Ryan Ono. And I'm going to let you give your talk, and if you are at all interested in joining CMS applications, providing suggestions for speakers, just send me an email or contact Sabrina or Lucia. We have a sign-up list in the back, and there's also coffee and refreshments that have been sponsored by the Joint Center for Climate Change, so JGCCC. I apologize, the acronyms are getting longer. So Jeff, with no more delay, and thank you.
Thank you. I didn't even do anything yet. Like she said, my name is Jeff Waters. I work for an organization called Ocean Conservancy here in Washington, D.C. We're based in Washington, D.C., but we have staff all over the country, from Alaska to Florida and everywhere in between. We are an environmental organization who focuses on U.S. ocean policy and finding solutions to all of these tricky problems that face our ocean environment today. So if you will indulge me for a little bit at the beginning here, I'd like to start out by reading a little bit from some testimony. This is congressional testimony from a shellfish fisherman named Brett Bishop when he testified for the Senate Ocean Subcommittee in the Commerce Committee. This is back in 2008, in May of 2008. It was a field hearing in Seattle that I helped staff for my former boss back when I worked in the Senate for U.S. Senator Maria Cantwell. And these are essentially Brett's words on ocean acidification and what the industry was facing back then. And this is a moment in time, just so you know, when the industry was just starting to piece together that some of the major problems that they were facing had to do with ocean chemistry, carbon chemistry, and with this phenomenon we know as ocean acidification. So these are Brett's words. My name is Brett Bishop, and today I am representing commercial shellfish growers on the Pacific coast from Alaska to California. My family's farm is on the Little Skookum Bay in Mason County. We are a traditional family farm with tides. My parents live next door. Mom is 91 and Dad is 93. My two teenage boys are the sixth generation to live on the old homestead and grow clams and oysters in Little Skookum Bay. We're typical of most other shellfish growers, and we are all facing unprecedented problems. Our largest producer of larvae, Whiskey Creek Hatchery in Oregon, has in fact had to close their doors temporarily and lay off staff. Growers have been donating funds to Whiskey Creek to help them in research for their solutions for their hatcheries. I need to be clear about this. The current situation puts both marine ecosystem and shellfish growers in extreme jeopardy. Diminished natural reproduction coupled with failing hatcheries puts us in a position where we stand to lose it all. From the perspectives of the Bishop family, it looks like this. We've invested everything we have and everything that we are in our farm. We have been growing as we could afford to for the last 124 years. We have a mortgage with Farm Credit Services. We employ 27 people year-round with gross sales of $2.8 million. If we can't grow our shellfish, the bank will foreclose on the mortgage. We will lose the farm, our homes, and 6 generations of our hopes and dreams and investments. That is most of everything that we hold dear. So the talk that I'm going to give today is not exactly a technical talk. The people in this room, obviously you all know far more about the science than I do. I have academic training. My academic background is in science. I have a master's in limnology and marine science from the University of Wisconsin-Madison. I initially came to DC for a fellowship at the National Academy of Sciences at the Ocean Studies Board, as well as for a Canal Sea Grant Fellowship, where I was placed in the Hill in Senator Maria Cantwell's office, and then got sucked into the policy realm and the Congressional realm when I stayed in her office for several years, staffing her chairmanship of the Ocean Subcommittee, ultimately for 4 years when I was with the Senator, before I came here to where I am today at Ocean Conservancy, doing government relations and advocating on behalf of healthy oceans on the Hill and with the administration. But what I'm here to do today is not to talk about the science that many of you are familiar with. It's to talk about you, and to talk about people like Brett Bishop, and about connecting the two. Not that you're necessarily going to interact directly with people like Brett Bishop, but the idea is that if we as a country are investing lots of money and time and resources, and certainly you're investing your careers and time and lives and work days to this important research to understand what's going on with carbon in our planet, we need to make sure that all of that science translates into policy. We need to make sure that the people who ultimately make the decisions that affect people like Brett Bishop and the shellfish fishermen are at least aware of the science, and that the work that you folks do can help inform that. So I know it's easy to get disillusioned, particularly in today's political environment. I'm on Capitol Hill quite a bit. I know it firsthand. And I'm sure many of you, feel the same way when you go home and you turn on the news and you see a story on the news about climate change or about, what's going on with carbon emissions, and it's all wrong. They're saying it wrong, and you want to throw something at the TV. But I'm here to say that despite the fact that it can be frustrating, your work is absolutely essential, and that there is certainly hope. And if I accomplish nothing else during this hour that I have with you here today, I hope to convince you of the statement on this next slide. Now, it's possible that I'm being a little bit dramatic here, but I really do mean what I'm saying here. So my thesis here is that millions of people depend on the insights that your research can provide. So you, the people in this room, and the people who are watching online, and I say millions of people not necessarily because millions of people are going to dig into your data and look up your articles and things of that nature, but ultimately millions of people, whether it's ocean users or whether it's anyone else who's impacted by what happens to carbon in the atmosphere and in the globe, are ultimately impacted by the decisions that we make and what we know and what happens with carbon across the planet. So I'm not saying that, the science produced by this group is going to be rock star science, that everyone and millions of people are going to know that paper, that really amazing paper that someone, one of these projects just released. But what I am saying is that connecting the science to the people that matter to guide decisions is something that is absolutely essential. So I'm going to walk through very briefly and the situation with ocean acidification, just because some of you may not be terribly familiar with it. And ocean acidification from our vantage point at Ocean Conservancy and from the vantage point of many policymakers is kind of a multi-tiered problem. And so, the most basic, which is probably what many of us are very familiar with, so I'm not going to spend much time with this particular graphic here, is the chemistry problem. The fact that there are, carbon emissions going into the atmosphere, more carbon in the atmosphere gets absorbed by the oceans, more PCO2 in the oceans, ultimately reduces the pH and has impacts on ocean chemistry. So that's the basic chemistry problem. It's pretty simple, pretty straightforward, relatively speaking. The biology problem starts with these tricky little molecules, though, in particular aragonite and calcite. And so this is where things start to get really interesting from the perspective of policymakers and the perspective of people like folks like me at Ocean Conservancy who care about the critters, who care about the living things in the oceans, because these molecules and the forms of these molecules are very critical in terms of how many organisms build their shells and their organisms, and essentially the entire food web is based upon this. So in this graphic, it's slightly counterintuitive. So the purple and blue is bad, and the red is actually pretty good. Because in the ocean, as many of you I'm sure know, aragonite and calcite at the surface level where most organisms live and thrive, the ocean is super saturated with this stuff. And so it's extremely easy for organisms to pull these molecules out of the water column and use it for their growth. It doesn't take a whole lot of energy. But the deeper you go in the water column, you eventually reach the saturation state. You reach that saturation horizon, and then once you go deeper below that, you get to undersaturated water. And any organisms that are in the undersaturated water, deep in the ocean, it requires more energy and certainly different physiology and biology to be able to extract these molecules from the water column that they need to live and grow. And so the problem is that as we are acidifying the oceans and as the oceans are absorbing carbon dioxide and as we are ultimately changing the chemistry of the oceans, these saturation horizons are slowly drifting upwards, closer and closer to the surface. And as you can see, particularly in the North Pacific and in certain areas, that saturation horizon is getting much closer to the surface than many people would like. And that has huge consequences for organisms and ecosystems that we're just now beginning to grapple with and to try to begin to understand. So it becomes a coastal problem, and in particular on the West Coast in states like Washington State, which is where Brett Bishop is from, and Washington and Oregon, where many of the shellfish industry folks who are kind of the first to be impacted in a major way directly by ocean acidification, because they live in this coastal zone. They grow their organisms, and their livelihoods rely on this coastal zone. And so as that saturation horizon is creeping upwards and upwards, we have reached the point where there's seasonal invasion of the corrosive undersaturated waters into these coastal zones. And that may not necessarily impact the growers of shellfish right away, because once you have adult oysters and clams and other organisms that are relatively well established, it takes really corrosive water before you have a major impact on them. But what Brett Bishop was talking about in his testimony and what the industry on the West Coast of the United States has had to grapple with is the fact that when you bring this corrosive water into a hatchery where you're trying to breed oysters and where you're trying to grow larvae, those really vulnerable larvae have a really hard time. And initially, they thought they had a bacteria problem when they first started saying, massive failures in their hatcheries, where the larvae just all of a sudden, all of the hatcheries all up and down the West Coast they just suddenly couldn't grow larvae. And this is not a problem that they'd ever really encountered in a major way, and it hit everyone, boom, at the same time. And it was only after a few years of kind of working with some folks at NOAA, in particular Dick Feely over at NOAA out in Seattle, that they were able to start to piece together that this is really about ocean chemistry, it's really about carbon, and it's really about ocean acidification was a significant culprit here. So this, I will also mention, though, that while we're talking very much about atmospheric carbon dioxide, in a lot of these areas where shellfish industry is present and where there are critters that environmentalists like me care about, these are estuaries, these are bays, these are coastal environments that that aren't just impacted by what goes on with atmospheric CO2, but that can also be exacerbated by what goes on with nutrient inputs, with eutrophication, which can exacerbate essentially this phenomenon in a more enclosed environment like Hood Canal and the Puget Sound. And then finally, that ultimately ends up as the people problem, because these oysters come from the water to processing plants where many people are employed, and ultimately to people's dinner tables and restaurants, all across the country. And so the people problem and the coastal problem, this is where most people like me tend to operate, and where people who are involved in policy tend to operate. This is where people on Capitol Hill need to respond to their constituents. So it may be a bit of a long way from the global carbon situation all the way down to ultimately the people problem. But I just want to impart upon you that it's the people problem that many of us focus on, and it's the people problem that tends to get action. And this is very personal for me because I was in Senator Cantwell's office when this first, the oyster situation on the West Coast first emerged as a significant issue. And I can't explain to you what it's like to have a group of people from a state that you represent walk in, sit down at a table in front of you and say, our industry might be gone in 3 years, and we don't know how to fix it. That's a really scary feeling, particularly when at the time they initially didn't know what was going on. And so the science that led them to be able to understand that it was the corrosive, undersaturated waters, and to be able to figure out how to adjust their intake pipes and to figure out how to manage their hatcheries in a way that would allow them to continue to grow larvae. That's a success story, but if that science hadn't entered at just the right time to tell them what it was that was about to put them out of business, it could have been a very different ending to that story. I also want to mention that, Ocean Conservancy, our work that we do and many advocates, our messaging and our communications focus very heavily on the people end of the problem. Because unless it's real, unless it's tangible, unless it's something that someone can see or hear or talk to someone who's been impacted, it's difficult to get people to take action. And so, in a very real way, even though it's this huge global problem, and it's really tempting to say, we need to talk, look at how big it is, it's so huge, we need to fix it. Ironically, the best way to impart upon people the urgency of the situation is actually to narrow the scope and scale of what you're talking about to something that's real and tangible and human. And what's even more frightening is what happens next. The oysters were the first to be hit, and the shellfish industry on the West Coast was the first to be hit. But we know so little at this point about what the ultimate implications are going to be for a wide array of organisms in the ocean. And by virtue of the fact that we depend on those organisms, we don't know who in industry is going to be, or what communities are ultimately going to be impacted. Is it going to be salmon fishermen and people who rely on salmon for either commercial fishing, or potentially for subsistence fisheries, like many of those that exist up in Alaska? Any number of finfish might be impacted. We really don't have any clue. And ultimately crab and the cute little kitties that rely on their scraps, also could be implicated. Chris Long over at over at NOAA and the National Marine Fisheries Service has done some experiments on the physiological impacts that altering pH has on king crabs and tanner crabs. These are the kind of crabs that in the deadliest catch, that the folks in Alaska go out and they risk their lives every day to go out and catch these crabs. And the results are frightening, that there could be some potentially serious physiological impacts on growth and reproduction on many crab species. And of course, the list goes on. Could it be lobsters in Maine? Could it be scallops on the East Coast? And the short answer is that we really, really don't know. And, this isn't just a chemistry problem, as you might have guessed. It's not just about where that saturation horizon is. And it's not just about the basic physiology of which organisms are going to be impacted by, the altered pH or the altered carbon chemistry of the water. Because it's not just about the physiology. And like I said, I went to the University of Wisconsin-Madison for my degree. And the LTER, the NSF Long-Term Ecological Research Program in the Great Lakes up there, did some really interesting work that can be considered as a rough analogy back in the 80s when we were worried about acid rain. So what they did is they got funding to do a multi-year experiment in a lake. It's a tiny little lake called Little Rock Lake up in northern Wisconsin, and they put a curtain down the middle of this lake, and they essentially used an entire ecosystem, and they had a control side of this lake and an experimental side of this lake. And so they spent 1 year just collecting baseline data, and then they spent 2 years each at a different, newly altered pH level. I believe, so it was 2 years at a pH of 5.6, 2 years at 5.2, and 2 years at 4.7. And it's a fascinating set of experiments where you can see that the most surprising impacts in that ecosystem, which is easy to study, relatively easy to study because it's a simple trophic system, and in a small lake you can actually count things and have a reasonable idea of what's going on. The most fascinating impacts were the ecosystem impacts. It was the reverberation through the system, not necessarily the direct physiological impacts. And so if that has any lessons for what might potentially happen in the ocean, that tells us that it's not just about the physiology, it's about the ecosystem impacts, and we don't necessarily know what's going to happen. And there was another fisherman who testified at another hearing that I helped staff for Senator Cantwell a few years later in 2010. His name was Donald Waters, and he had a really challenging job because we also invited Sigourney Weaver to this hearing so that she could talk about ocean acidification. It's an issue that she's very passionate about. And, we were like, how is anyone on this panel going to be able to, stand up to Sigourney Weaver because she's going to put on a great performance and be so emotional. And I'll tell you, Donald Waters blew Sigourney Weaver out of the water. I mean, she was nearly in tears when he got done talking. Because he just pleaded with people. He's from the Gulf of Mexico. He's a fisherman. They're not necessarily seeing impacts right now, or at least not that they know of. But the question is the fear of not knowing. And the thing that he said in that hearing that I think is just fantastic is this. This is a devastating ghost lurking in the shadows. That is how he described ocean acidification. As someone who lives on the water and relies on the ocean for his livelihood day in and day out. And I just think that's very telling, that's the way many people feel right now. And people want answers. They are desperately seeking answers from the scientific community and from projects like the projects that are part of this group. So this brings us back to our thesis. If millions of people, like Donald Waters, like Brett Bishop, like all of the, salmon fishermen, crab fishermen, all of the folks that are out there who either are being impacted or who might be impacted, if they rely on the research that is being done on carbon, and you could expand beyond this. It isn't just fishermen on the water; it's anyone who relies on anything having to do with carbon on the planet. Then the question is, how can we connect with those who need it? Or more accurately, how can you connect your work with the people who need it? So that's the question that I would like to focus on for a little bit. And I think that before we really delve into that question, I need to have one little reality check. And this is a warning and a recognition that I'm sure many of you are familiar with, but I have experienced at various points in my career so far in ways that I didn't anticipate back when I was a grad student and had full access to all of any journal article you can imagine and the library databases. I mean, it's amazing what is at your fingertips when you were a student in an academic institution. But then you go to Capitol Hill, and you would think that you would have those things at your fingertip again. You have the Library of Congress, after all. They have everything, right? And yes, they do, but it's important to recognize that it is not like an academic institution. It is really, really difficult to get your hands on to primary sources, academic research, academic journals. You can do it if you know what you need. Like if you know that you have a citation, you have an article that you need to look up, you can go to the Library of Congress and email them, and you can call them, and they will get it to you in a few days. But it's not like sitting there with your database at the university where you can click through abstracts and look through what's the latest in the literature. It's a much more laborious process. So I think, and that's also the case in many environmental organizations and advocacy organizations and people who deal with policy. We do not have the access to academic journal articles the way people in the academic community necessarily do. And so in a lot of ways, I just want to make that point and say that it's probably a safe assumption that anyone who's dealing with policy or anyone who is a stakeholder or anyone even on Capitol Hill, that those journal articles are behind a very thick locked door. And it's very difficult to get. It's not impossible, but certainly perusing through the literature to see what's the latest that these brilliant scientists are coming up with, it's not from academic journals. So journal articles, which we prize so much, it is not something that is actually going to reach a whole lot of people. So that, for me, just emphasizes the need that putting things online is essential. Whether it's data tools, whether it's summaries, whether it's syntheses. And I think there's an analogy here to what you've seen the field of macroeconomics do over the past few decades, where they have very much moved away from the journal-based model. There are still academic journals in macroeconomics, but a lot of the real work, the real-time work, analyzing what's going on with the economy is happening in blogs and reports put out by the IMF and central banks, and there's an ongoing dialogue that is much more accessible and much more public than what typically happens in a lot of the rest of academia. So what can we do? So I'm basically going to walk through 5 areas, and this is where I'd like a little bit of feedback and ideas from the group as we kind of look at each of these kind of broad recommendations in terms of what can we do to make sure that the science translates into the realm of policy and gets to the people who matter. So when you're trying to come up with something online to present your work, to present your research, to present your data, I think the first key lesson is to not focus so much on the data. It's great to have the data there, but in preparing for this talk, I tried to look at a lot of different data portals and people who have attempted to start to put their work online. And I think a common mistake that I started seeing, that was a common thread in a lot of sites that I looked at, were people just throwing data up online, or even data visualization tools, which looked really cool, but to be honest, if you don't show what the data mean, it's actually worth very little. Because the average person who is not an expert, who is not in your field, who does not have the wealth and background of knowledge and expertise that you folks do, don't necessarily know how to interpret that data. And so start with the meaning of your work. Start with what you're trying to convey. Start with what you have learned. And then present information and data that will help show that will help tell that story. But simply putting data up and visualizing data for the sake of just visualizing data without any meaning is actually not a very effective way to go. So I can think of some examples. So if folks can think of examples of maybe a website, and let's get away from carbon. Let's think of other areas of interest. Maybe you've been looking at economics stuff or information on politics or demographics or anything. I mean, has anyone seen a website or a portal where there's a really complicated set of data that was just presented in a way that told an instant story and just made you go, wow, I know something now that I didn't know before? Does anyone have any examples that they can think of? Please raise your hand if you do. So I know I'll come up with one example is the AtlanticCities.com. It's an interesting portal, and they often put really complicated data into a map format in a way that tells an instant story, so that you know that, oh wow, the demographics of where bad environmental policy happens overlaps with the demographics of where poor people tend to live. There's a lot of data that goes into that. Holy cow! I know something now that I didn't know before. So that's just one example of a website that even though I'm not necessarily referencing it for work, just the stories are so compelling that I find myself continuing to go back there time and time again. So my next kind of broad point, so 2 out of 5, is when you're talking about your models. I have to say, models are an interesting topic for me, because for me and for many other people, models are so intimidating. I mean, I did some modeling in grad school for, in population biology things, but nothing on the order of what many of you folks do. And I think that, many people, even, individuals on Capitol Hill and who deal with policy, when they hear the word model, they think of, someone strutting down a runway, or they think of, a model airplane or a toy. So the concept of using a quantitative model is something that is not an everyday occurrence for many people who ultimately make policy decisions. But I think it's important to make sure that when someone presents a model to people who are non-experts, it's not about the model itself. What we really need to have conveyed are the insights that the model provides. And a perfect example for me is something that many of you may be familiar with. So I don't know if you may have heard that formerly was a New York Times blog called 538. Now it's essentially on its own entity. But this guy named Nate Silver, who is a statistician by trade, and he basically does something very complicated and yet very elegant. So what he's really good at is taking polling data from across the nation, and he tends to pop up a lot each election cycle, and is in the news a fair bit. So there are all these polls all across the country on who's going to win, who's going to lose in any given election. Let's just take the presidential election, for example. There are different polls in different states. All of these polls have different sets of assumptions, different political leanings. Some of them are independent, some of them are Democratic leaning, some of them are Republican leaning. They have different sample sizes. There are huge amounts of uncertainty and different methods associated with all of these polls. And what Nate Silver does at 538 is he basically comes up with a model to bring together all of this polling data and to come up ultimately with our best guess at what's going to happen. Based on the polling today, based on everything that we put together in one big quantitative model, what does it look like? And when he presents his information on his website and in the press, you can find all the information you want about the model itself. It's all there. But he doesn't talk about the model. He talks about what he's learned from the model. What are the insights that he's gaining, including caveats and uncertainty. But I just want to convey that it's about the insights that the model provides, not necessarily the model itself. And that's what's most helpful to people on the outside of academia who ultimately will be making choices and decisions on these important issues. So the issue of scale is another area that I wanted to discuss. And it's an area, like I said earlier, when, the politicians and advocacy groups like Ocean Conservancy, when we tend to work with the human side of the problem more often than not, this is a recommendation in terms of, whenever possible, bringing the work down to the human scale. It's really tough. I totally get it. In some cases, it's impossible. But it's just something to be wary of, that whenever you can, it's really good to try to do that. Because it's the human scale that matters, that is relatable, and that is understandable for people who aren't involved in the global science and these big, huge, knotty questions that you folks are involved in a day-to-day basis. And, one example that as I was prepping for this talk, an example that I came across in a book was really fascinating to me, and it's too bad I wasn't able to get a visual for it, but Cisco Systems years ago had a problem where they were going to try to present to a group of clients, they were going to try to present this big new logistics system that they had put together. It was this complicated nationwide system for managing the flow and data of the flow of products across the country. And, their initial slide trying to explain that system was all about, it was all about the system and all of the components and the data flow and the arrows and this and that. And it was enormously complicated and extremely difficult to convey to people in a way that was understandable. And so what they ultimately ended up doing is they ended up deciding instead to say, look, our big new system that we've invested in here, it's great, it's fantastic, but it's not about the system, it's about what the system is going to provide for people and for customers. So they ended up instead trying to relate this big system to the human scale by telling a hypothetical example of a guy who makes beer. A guy who has his own microbrewery, and he relies on getting the best hops possible to make his award-winning beer. And this situation where the hops that are on the way to his brewery, the Cisco system informs him all of a sudden that those hops have run into trouble at customs and is not going to make it. And so they've set up a problem, and then they basically say, and look at we're going to walk you through how our system is going to fix that. So the magic is going to happen because of our new logistics system that we've set up. And then let's show you how it's going to fix that problem. So, sometimes when we get into these, big, huge scientific debates and models and scientific issues, it's difficult to bring it down to the human scale because the questions are so big. But I think that it's often possible to bring it down by showing the magic. What does it ultimately mean or potentially mean to a person at the end of the day? So number 4 out of 5, we're almost done here, is don't forget context. It's always important to remember that when trying to convey research and data and information and the work that you've done that people need so desperately, most people who may look at that work from outside the academic community, they don't have the knowledge and the background that you have. And so giving people the context and the tools to understand what the work means is really, really critical. If we're going to talk about carbon flux, for example, I'm sure there are many people in this room who talk about carbon flux all day long. But if you're going to talk to someone on Capitol Hill, the first question they're going to say is, what on earth is carbon flux? What are you talking about? What does it mean, and why is it important? And I think there's definitely been a movement, certainly in journalism lately, to move towards explanatory journalism. Ezra Klein, who used to be at Washington Post and has now set up a website called Vox.com, is all about explanatory journalism. It's all about providing the context so that people can understand ultimately what's actually happening, and recognizing that the average person, when they pick up an article on any given issue, they don't necessarily have the knowledge to know that. So providing context is certainly something to always keep in mind. And finally, I know that the first talk in this series focused a lot on uncertainty, so I don't want to focus on this too much, but I think it's important to own your caveats and uncertainty, not to let the uncertainty own you. And in a lot of ways, it's uncertainty is the fog that clouds what we'd like to be able to say. But I think that handling uncertainty in a way that is upfront, but still doesn't prevent us from saying the insights that you've actually learned. You have learned something from your work. So what is that? And we can say that there's uncertainty around it and that we may not be 100% sure, but we have a good idea because we have a lot of smart people who've invested a lot of time and enormous brain power, far more than I have, to try to figure out what's going on in the world. So that's it. Here are the 5 things. Here's the general roadmap that from people from my perspective at Ocean Conservancy, from people on Capitol Hill, from people in the policy realm, from the stakeholders that we deal with day in and day out at Ocean Conservancy, and the folks who really need the insights and the knowledge that the people in this room are producing. These are the 5 big things that I think are really important to try to think about and consider when you think about developing products to try to convey your work to the outside world and to people outside of academia where it may potentially influence policy or play a role in decisions that are made. But I think the even bigger lesson for me here is that this is difficult. I mean, I can see it in the room. There are a lot of skeptical faces because this is really tough to do. And I think the thing that I'm hopefully convincing you of is that this takes time, effort, and thoughtfulness. But if it's going to work, it cannot be an afterthought. And that it is so worth it to invest the time and the effort and the energy into doing this because this is where the rubber meets the road, and this is where the work matters to people outside of academia, and it matters for people who are desperately trying to make the right decisions for our country and for our planet. So, I know that I've focused a lot on some of the individuals impacted by acidification earlier, and I once again, going back to my main thesis, that millions of people really, really do depend on the incredible, amazing work that the folks in this room and online here are doing day in and day out. I want to show you a few of those faces just to reemphasize that. And so this is Pete Knudsen. He's a salmon fisherman out of Seattle. Really great guy. I love his hair. This is Brad Warren. He works for a Sustainable Fisheries Partnership, which is an NGO, essentially a group that works with commercial fishermen and aquaculturalists across the country on all sorts of environmental issues, including ocean acidification. Brad has been pounding the pavement on ocean acidification with members of the industry for years, far longer than anyone else, and long before anyone else recognized that this was going to be a huge problem. This is Bob Rowe. He's the executive director of the East Coast Shellfish Growers Association. He comes to us out of Rhode Island. This is Terry Williams. This is a phenomenal man who I was able to get to know a little bit in my time when I worked for Senator Maria Cantwell. He's a member of the Tulalip tribe in Tulalip Bay, Washington. He relies on salmon, and his people rely a lot on salmon. And he's done some really interesting work partnering with dairy farmers to come up with creative solutions to reduce runoff that contributes to ocean acidification in the Puget Sound and in these kind of more constrained oceanographic environments. This is Perry Reso. He's an owner of an oyster farm and bar down in South Kingstown, Rhode Island. He's also doing some fascinating work, and if you're ever in his neck of the woods, you should totally go to his place and eat some oysters that he's grown. This is Katie Chefnet. She works at Taylor Shellfish Farms in Shelton, Washington. This is one of the shellfish companies, one of the largest on the West Coast, and it was one of their hatcheries, or one of the largest hatcheries on the West Coast, and one of the ones that were hardest hit by acidification a number of years ago, until they were able to get the right science to figure out how to work work around the problem, at least for now. And then this is Marco Pinchot, who also works at Taylor Shellfish Farms. There are a lot of people who work at Taylor, and they're a really great company. And finally, this is Mica Macari and some of his kids, his children. He is with the Macaw tribe in Nia Bay, Washington. And the Macaw tribe, I think, have a very special place in many people's hearts because who deal with ocean issues, because they are people who, throughout their history, have relied very, very heavily on ocean resources for their lives and for their community and for their culture. It's not just shellfish, it's salmon, it's ground fish, and it's whales, it's whaling. And they have a treaty tribe. They're a treaty tribe, and we, as a country, have treaty obligations to the macaw to make sure that we are stewards of the natural resources that they depend on. So, with that, I thank you for the time, and I thank you for letting me introduce you to some of the people who we work with and who we have interacted with over the years. And I hope I've been able to convey to you that the work that you do, even though not all of you work on ocean issues, the work that you do matters. And it matters to actual, real-life people in places all across the country who you will never meet, and making sure that the insights that you glean from your research reach, if not them, the people who are making decisions on their behalf and making decisions that impact them is crucially important. So on that, I'll take any questions.
Listed 5 points. The first 4 are quite succinct and have examples. The 5th one is completely different. You've got to put that into the same structure in some sense as the first 4, such as, here are my uncertainties. Even 100 people, why the healthy ones are 99 of these, so you show one that
Yeah.
You've got to do the same things you advocated in the first 4.
Yeah, so the question was about the last of the 5, so on the caveats and uncertainty. Like I said, I didn't want to devote too much attention to it, since the first talk in the series was devoted entirely to uncertainty. But your point is well taken. And I think that, once again, to refer to an example that I see, I think a great example is, once again, Nate Silver at 538, where if you look at his articles and his conclusions, the uncertainty is all there, and he's very, very explicit about it. It's not necessarily the headline, and that's the amazing thing about the internet, is that there is no limit to what you can put up there, but it doesn't necessarily have to be the main headline. And so the advantage that we have with online, even more so than in a journal article, where you're constrained by what you can put in print, and you're constrained by the length of the article and the word count and things like that. Online, you can put it all on there and simply link to it, so that those who want to really dig into the uncertainty can do that, if they want to dig into all of the caveats and things of that nature. So I think there's a lot of flexibility in how one can do that. But I think it's important to, in the way I tried to state it is, make sure you own the uncertainty and that it doesn't own you. Start with what we know and what you've learned, and then you can premise that and expound on the uncertainty. But starting with all the things we don't know is not a very effective way to convey to someone what it is that we've learned.
Yeah, that's what you got around to what I think is the key point for scientists, which is when you're talking to a scientist, what's really interesting is the uncertainty.
Yeah.
This is what I don't know. And then, because then we can talk about...
Because the uncertainty is the questions.
But
Yeah.
talking to the rest of the world, what they hear is scientists leading with the uncertainty. And so then they think, we don't know anything about what's happening on the carbon side. Well, we know a lot, really solid. So we lead with what we know really well to the public. The decision makers want to know what we know about the carbon cycle, and we've got it nailed. In fact, there's a lot that we do. And I think the frustrating thing, I guess my question from the science point of view, where I think all of us are tremendously frustrated with the policy realm. And most of us who are doing basic research want to just go back to our research and say to hell with policy, is that we think we've nailed the things that are really crucial to policy, in the last, it's decades even. And it's like shouting into a barrel. They're obviously not listening.
Yeah.
And you can't just communicate by shouting louder.
Well, so on that point, I think that's a perfect, I'm so glad I'm talking about ocean acidification in the fact that you brought that up. Because ocean acidification is this interesting, well, yeah, I mean, it's a carbon problem, and it's obviously related to carbon emissions, and, there's clearly a link in terms of the root cause to carbon emissions, to climate change. But we've done a lot of, interacting with people and focus groups and public polling, and to try to figure out how do people perceive ocean acidification, and how does that compare with climate change. And the climate change thing is tricky because it has become such a political fight. It is part of what you believe about climate has to do with your identity. It has to do with your friends and what they believe and politically who you affiliate with. When you talk with people about ocean acidification, you see this very clear schism where if you talk about ocean acidification on its own, there is an enormous amount of receptivity. I mean, people get very concerned very, very quickly because it's a compelling story. But if you bring ocean acidification up and introduce it to people at the very beginning, in the context of climate change, you lose half the people immediately. And so I totally get the frustration because we're right there with you. This is a dynamic that we have to deal with as advocates and as people who advocate for environmental policy. But understanding with ocean acidification, I think there is a unique opportunity to be able to say, look, most people don't know about ocean acidification, and there is certainly a chance to have a really solid dialogue on this issue in a way that, unfortunately, we've gotten away with other issues like climate.
Can you talk a little bit about what sort of experience or requirements that on Capitol Hill people have for hiring science policy advisors? Do they have any? I mean, sometimes it feels like they don't, but, oh.
Yeah, so
the mic just got closer to me. Okay, I'm done.
So she asked about what kind of requirements on Capitol Hill do people have if you're going to hire a science policy advisor. I'll start out by saying some of the smartest people that I have ever met, I met on Capitol Hill. And that is an honest-to-God true statement, whether they have scientific backgrounds or not. I mean, what it takes to work in that environment where you are dealing with just scores and scores of issues on a daily or hourly basis, I mean, it takes a very, very smart person to do that. Now, in terms of your specific question on what kind of qualifications are required, every congressional office and every committee has their own individual policies. So there's no blanket kind of like requirement for hiring anyone on Capitol Hill. It's up to the member of Congress as to who they want to hire. But I think that some of the most important, sources of really quality, individual staffers on Capitol Hill who have scientific backgrounds are the fellowships. And the DTLE, many folks who would go on to be DTLEs from federal agencies, from Department of Energy or from NOAA. It's how I, came to be on the Hill was through a fellowship. And I think that's a really crucial mechanism for getting people with scientific backgrounds onto Capitol Hill. But the short answer, which is not very satisfying, is there is no specific standard because it's up to every member of Congress.
That's kind of what I thought. But
Yeah.
We have a couple of questions online. Let me get one online and I'll move right to you. It goes back to uncertainty. And essentially the question is, how do we translate uncertainty for policy? How do we change the vocabulary? Because as scientists, we look at uncertainty in terms of range of confidence. How do we change the language so it actually resonates better with those making the decisions?
Yeah, so I think that I would give a two-part answer. So I think it's always important to try to base the expressions of uncertainty in quantitative terms, because there are folks who will come across the information, like myself, who have a background in science, and I understand the probabilities, and I understand what's going on when we talk about confidence intervals and things of that nature. But it's also equally important to express uncertainty in qualitative terms, that if you were to try to explain to your mom, how certain are we? Are we pretty certain? Are we almost entirely certain? Are we, we just sort of have an idea, we think maybe? So I think it's, in my view, it is important to be able to express uncertainty in both quantitative and qualitative terms, so that no matter who's looking at the work, you can reach them. Yep.
At the beginning of the talk, you show some very...
You can let it go.
At the beginning of the talk, you show some compelling stories about the oyster farmers and all that, and that's a success story that really grabs attention. Are you aware of any other success stories looming on the horizon, or are you seeking others that you think are candidates for the same kind of impact?
So I think on ocean acidification specifically, the success stories that we are hopefully setting ourselves up for are stories where we prevent something from getting to the point that the shellfish industry got to on the West Coast. The shellfish industry is kind of the only example where you had an industry totally on its knees, and it was a very instructive experience for policymakers. And obviously I was on the Hill at the time and experienced that. And when the industry first came to Capitol Hill and came to the agencies, there was no ocean acidification program at NOAA. There was no legislation on this issue at all. And they were begging for resources. They're like, we need, some money, just a few $100,000 to be able to monitor the carbon chemistry of the water that's coming into our hatcheries. And there was literally no grants program that they could apply for. There was no way for them to solve the problem. So for that initial year, we worked on getting an earmark, and it was lucky. Once again, timing is everything. It was the very last year of earmarks. And so there was a $500,000 earmark to purchase scientific equipment for the industry. But that also put an exclamation point on the need for developing something more permanent that could head off these issues in the future. And so that was why Congress, at the time, the late Senator Lautenberg from New Jersey had put together a really fantastic bill called the Federal Ocean Acidification Research and Monitoring Act, the 4M Act, that we moved through committee because we needed to do something permanent to make sure that there were dollars for research and for monitoring for these kind of situations in the future. And so that legislation was enacted into law, and that's where the Interagency Committee on Ocean Acidification comes from. It was from that bill that we worked on, and that's where NOAA's Ocean Acidification Research Program comes from. They didn't have a program before that legislation. So in a way, I think that that's not a very specific industry example, but I think in a way that is a translation of policymakers responding when we had an emergency, and not just responding to that problem, but putting together a larger policy framework to deal with industries when they run into trouble, or to learn when they might be about to run into trouble before it gets to that point. Yep.
Do you think there's any chance that the Congressional Research Service will ever be reinstated?
So the Congressional Research Service does exist, and they provide an extremely valuable service to congressional offices. They are nonpartisan, and they provide research reports at a very, very 30,000-foot level. This does not get into the weeds of data or research or what papers are out there, what's the latest in the science, but basically to give a basic summary on any given topic issue. And it's actually interesting that you bring that up, because I was just looking at the ocean acidification report, a few weeks ago that CRS had put out, and it's a few pages and just kind of gives some of the basics. But it is designed for the 24-year-old staffer who knows nothing. As a staffer, I don't know how we would have gotten done what we got done without that resource.
Okay, we have one more question online, and this has to do with timescales. Most of the researchers here do reliable work and have confidence on climate change and acidification, and it comes from climate models which address centennial timescales. But it seems that the policies and the decision makers are working on decadal or even shorter scales. So what is your suggestion for linking the confidence in the research scale to the confidence in the decision scale?
Yeah, so that's a really great question. And it's one that folks who want to take action on carbon emissions are, I mean, if I had the magic answer to that question, I would be, the guy. But I think that in figuring out how to relate it to something that is much more immediate, one option, for example, is to talk about rates of change. And to put that in a context, for example, if you're talking about grandma's car that goes, 40 miles an hour, and, over the last however many million years, the change in the, the carbon chemistry of the ocean has occurred at, a pretty small rate. What is the speed that we're going at today? It's probably like the speed of the space shuttle or something crazy like that. I don't know exactly, and someone would have to do the math. But sometimes relating it to something that is understandable can get across the message that that we're really dealing with something significant here, even though some of the impacts that we talk about in our research may not necessarily show themselves for 50 or 100 years or something like that.
Great, thank you.